Yes. So in today's class, we are going to see the convolution neural networks. So whatever we have completed in the last class. So in the last class, we are discussing about the convolution neural networks and the theory part. Once we check the theory part, right? So the theory part is with respect to whatever the image. First, we are going to consider the image. For that image, we are going to apply the convolution. What is meant by convolution means applying the filters. Whatever the filters we are having, different filters we are going to apply. And for that, we are going to take the rail. First, we are going to apply one filter. And based on the filter, we are going to get some positive values and negative values. And post, we are going to apply the ReLU. And we are going to get only the positive values. Followed by max pooling. We are going to do the max pooling. Once the max pooling is done, now we are going to do the flattening. So where the flattening means, we are going to get the input layer. The input layer is called as flattening, and remaining we are going to have the neural network. This is the neural network, right? So one image we are considering. For image, we are going to apply the convolution, whereas multiple filters we are going to apply. And based on the filters, we are going to do the max pooling, and we are going to have this kind of thing. Sir, what it is finally it is going to do means the initial image, whatever the number of pixels are there, the number of pixels we are going to try to reduce. Means here, whatever the number of nodes, input nodes, if you consider directly the image, the input nodes will be very high. We are going to try to reduce the number of input nodes by doing this filtering plus max pooling technique. So once we have done this one, again, if you take directly the image and if you do the flattening also, you'll have the same thing. Without doing the filtering and without applying the convolution or pooling, you will get the same thing. So directly, if you take the image and if you apply the, in terms of what? Flattening, directly you will get the input layer. Now, instead of that, what we are going to do is, we are going to take the input image. For that, we are going to apply the convolution and max pooling. And once we are flattening, now we have got the input layer. And based on the input layer, we are going to take the neural network. Now, what happens? First, this is going to take first image. The first image, it is going to apply some filters. Based on that, some filters it is going to apply randomly. Randomly, some filters are applied. Randomly, weights are initialized. Randomly, bias is initialized. So randomly, it is going to do initially. And based on the output, whatever the output we have got, based on the output, it is going to adjust the weights. The weights will be adjusted in such a way based on the output, whatever the output is there, in order to reduce the error. It is trying to reduce the error. And it is going to adjust the weights. The weights will be adjusted not only in the neural network, the weights also will be adjusted in the filters. Different types of filters, it is going to readjust, right? The filters also going to be readjusted based upon the error, right? Now, the same thing which we are going to have is coding. So now we are going to see the coding part of convolution neural network. First, we are going to import the TensorFlow and Keras. Okay. So for our neural networks, TensorFlow and Keras, this already we have seen in the artificial neural networks, the same. Now first, image processing. For doing image processing, from keras.preprocessing.image, import the image data generator. It is available. So we are going to import the image data generator. So now is this image data generator, whatever it is going to do means, it is going to generate. It is going to generate the images. Whatever the images are there, it is going to take the images, and that image, whatever the image it has collected, it is going to divide by 255. Why you are going to divide each value with 255? Because the pixel intensity maximum value is 255. So we are going to scale down, divide by 255 means we are going to get exactly the percentage of how much color, exact color is there. That is red color, green color and blue color. So that, for that reason, we are going to do the 1 by 255. Shear range is equal to 0.2. What is meant by this shear range means, some images will be like this. Okay. Some images will be cross. Some images will be straight. So all the images will not be of the same. So for example, let us take like this. Okay. So here, if you observe this image, whereas this image is having with respect to the cheetah faces in terms of straight, whereas this one in the slanted one, whereas this one is bulged. Means in terms of it, now, for example, in this, we have to extract the face. Means what we have to do? We have to do the zoom, right? So here we have to get into the zoom. So that is the reason. So here, whatever some images will have tilted way. Some people will take their, actually the photo will be like this only, but their face will be like this, slanted face. Instead of having the face in this way, we'll have in the slanted way. So now whatever the faces we are having, whether it is in the slanted way, whether it is in a straight way, whether it is a less zoom or whatever it is, we have to consider all type of images. For that, we are going to consider the shear range of 0.2. Now shear range of 0.2 means 20% it is going to convert like this. If the photo is something like this, if the face is like this, it is going to increase to the 20 degrees. That is with respect to 20%, it is going to tilt. 20% it is going to tilt. And zoom range, what is meant by zoom range means it is going to magnify into the 0.2, means 20% it is going to into the zoom, right? This is called as image data generation. Image, there is an image. This one is 280 straight lines. How many straight lines we are having means 280 straight lines are there. From here to here, 280 straight lines you have to do. So this one is 300 straight lines. Now for each of them, this is 1 pixel. This spot is called as 1 pixel. In that spot, whatever the blackness or redness or blueness, whatever it is there, it is going to capture the color. The color will be in terms of RGB. And the intensities will be like 234. Intensity of 234 is there. 234 intensity, what I'm going to do? Divide by 255. Now I'm going to get in terms of percentage. So in order to get the percentage, what I'm going to do is I'm going to divide every value divide by 255. Okay. So divide by 255, shear range of 0.2 and shear range of 0.2 we are going to consider. Next, whatever the image data generator is there, this image data generator, I'm going to keep in a variable name called as gen, G-E-N. Now in this flow from directory means, so here from data set by training set. If you observe here, data set by training set means in my working directory, flow from directory means working directory. From my working directory, folder is called as your working directory. Wherever your Jupyter notebook is there, that is your working directory, right? Now in this working directory, you are having the data set. There is a column folder called as data set. In this data set, there is training set. It is going to open the training set. This is the training set. Now what it is going to do from the data set, within the training set, it is going to take flow from the directory. Flow from the directory means it is going to collect one image after one image. One after one after one, for loop. It is applying the for loop. Flow means for loop. One after one, it is going to collect from the given directory. In the given directory, there is a data set. Inside that folder, training set is available. In the training set, whatever the folders are there, you have to collect one by one, right? And target size is equal to 64 by 64. What is meant by this one means each image, whatever the image is there, for example, what it is going to do means, so whenever I have written this code, if I execute this code, what it is going to do, first it is going to open the data set. Inside the data set, training set, inside that cats and dogs. How many classes are there here? 2 classes are there. So first it is going to take the class mode is equal to binary. So 2 classes are there. So in the backend, it is going to create 2 classes, class 0 and class 1. In the backend, automatically it will create 2 classes since I have written the class mode is equal to binary. For example, multiple folders are there. Here you have to write multi-class. You have to write the word called as multi-class. Multi-class means how many folders are there? Those many backend one folder will be assigned. Right? Now, here the class mode is equal to binary. Binary means 2 classes. 2 classes it is going to take. What is the first class? Cats. What is the second class? Dogs. Automatically it is going to apply the, with respect to alphabetical order. So cats will come into the first, so it is considered as 0. Dogs will come next, so it is considered as 1. Right? Now, target size of 64 by 64. What is meant by this one means, now it is going to open the first cats. In the cats, what it is going to do? Flow from the directory. Flow from directory means one image after one image. It is going to collect all the images. How many images are there? It is going to take all the images. Just applying the for loop in the backend. So first it is going to take this image. This image, whatever the pixels are there, 280 pixels, 300 by 280 pixels, it is going to convert that one into 64 by 64. I am going to reduce that one to 64 by 64. Sir, how it is going to reduce? Just if you open your paint, okay, everyone knows this paint, right? So MS Paint, if you open here and if you select any particular image, if you drag any one of these, there is an option called as resize. Resize percentage wise means percentage. If you want, let us assume this is total 100% of image. If you want to reduce this image to 60% or 40%, just if you give that in terms of percentage means it is going to reduce in terms of percentage. If you give in terms of pixels, 300 by 280 pixels, I want this one by 64 by 64 pixels. I'm going to take 64 by 64 pixels and I'm going to click on the save. Automatically what happened? The size has been reduced to 64 by 64. Now this 64 by 64, whatever the pixels are there, this 64 by 64, I'm going to apply the various filters. This is the image. I'm not going to work on the big image. I'm going to convert that one to the small image. Sir, when you have converted this one to 64 by 64, automatically the clarity will reduce, right? The clarity will be reduced. That is the reason we are applying the multiple filters. We are not going to apply only on the single filter, right? So we are going to take the multiple filters. So now this is the 64 by 64 pixel is going to do the same. Target size of 64 by 64. Now each image, whatever the image is there, I'm going to get in a 64 by 64. If you observe this one, here what is the input size we are having? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 by 7. This is a 7 by 7. Yesterday's whatever the example we have done, that is X example. This is 6 by 6 example. Okay, where we have considered for 6 by 6, applied the 3 by 3 filters, and we have got the future maps and ReLU and max pooling, and we have done like this. Now here, just I'm going to take the initial image of 64 by 64. Okay. Now I'm going to get 64 by 64. So it is going to collect the, from the directory, it is going to take the two classes. So in your directory, where is your, this is data set, within the data set training set, two folders are there. Two folders means two classes. Two classes, total how many images are there means cat. See here cat, how many items are there? 4048 items are there. Coming to the dogs, how many items are there dogs? 4000. Total how many? 4000 plus 4048, 8048 images. So it is going to color the 8048 images belonging to two classes. Okay. And what are the indexes it is going to assign means? For cats, it is going to assign the index as 0. For dogs, it is going to assign the index as 1. In the backend, it is going to collect one by one. One image after one image, one image after one image. It is going to collect the images. Multiple images it is going to collect. Right? Similarly, test data. Test data, what we are going to do is, for training purpose, if the photo is like this, cross, if the photo is cross also, for training purpose, we have to convert that one to straight photo and then only we can process. But while testing, for example, let us, yesterday I have told you an example like cinema heroes are there. Cinema heroes examples, if you give like Prabhas, Mahesh Babu or other heroes, if you give the images, for training purpose, if I given the Mahesh Babu image, Mahesh Babu face is like this and completely inverse. Face is down and legs are on the top. The photo was inverse. Can you identify that photo properly? And that too, for the first time, if you are teaching for the machine, you have to give a proper one or a opposite one. So first time when you are teaching the machine, training should be very clear. So that is the reason in the training, we are going to do the fit underscore transform. Whereas in the testing, we are going to do only transform in the machine learning. Similarly, here also the same. While training, we have given the shear range and zoom range because that is training purpose. But while testing, just we are going to adjust the values to 155 only. We are not going to change the shear range and zoom range, right? Now, testing data. Testing data means it is going to take from the flow directory data set. Within the data set, test set is there. So it is going to collect from the test set. Target of 64 by 64, class mode is equal to binary. So again, once again in the convolution neural networks, data set, inside the test set, here also it is going to collect. So now if you see here, total 1000 images of cat is there. Total 1000 images of dogs are there. So this is the test data. Okay. So what we are having two sets. One is called as training set and one is called as testing set. In the training set, I am having 4048 images of cats and 4000 images of dogs. I'm going to train. First, the machine was trained on these images. It is going to apply the filters. It is going to adjust everything. the neural network is going to be designed. The weights are getting updated. Now, finally, I'm going to get the final weights. Once the neural network was designed, completed, everything was completed. Neural network was designed and everything was completed. Now, I'm going to send the testing records into that. 1,000 of cats I'm going to send. Out of 1,000 cats, how many it has classified correctly? Out of 1,000 dogs, how many it has classified correctly? I'm going to check. 1,000 or 100 or 50, whatever it is. Yes, you are going to check with respect to the accuracy. To check the accuracy of the mission, test accuracy, we are sharing the test data. So here, whatever we are having, so this one, train data, test data, total 2,000 images from 2 classes, 8,048 images from the 2 classes. Training set is entirely different, testing set is entirely different. Is that clear? So in the last class, I have told you the same. So while training, I have trained the machine completely with letter O. I have trained the machine with completely with O, and I have got the neural network. And once the training was completed, now I have shared the X. This is testing. And yesterday I have given you one example. I asked you to do this one. For this one, what is the expected answer? Check for this. That is testing. The neural network, have you changed the neural network? No, the neural network was fixed. In the yesterday's class, whatever the initial 4 neurons we are having, 1 hidden layer neuron and 2 output layer neurons. This neural network is already fixed. Whatever the neural network you are having, this is already fixed. Weights are already fixed. You are not going to change the weights. W2, W3, W4, W5, W6. Weights are not going to change. B values are not going to change. In this case or in this case, the B value is not going to change. You are going to send a new image. A new image of like this. And you are going to check whether it is a X or whether it is a O. Right? Similarly, here also the same. First, I am going to train the machine. First, I am going to train the machine. Once the training was completed, now I am going to share the test data over that one. Right? Now, modeling. So, how to create the model? Means, first we have to initialize the CNN. We are going to initialize the CNN. How we are going to initialize the CNN? Means, any neural network initialization will be sequential. Sequential means whatever the order I am going to give, you have to execute in that order. So, keras.models import sequential. Right? Now, first step. What is the first step in this? What is the first step we have to do? For any image, first step we have to do is convolution. What is meant by convolution? Applying the various filters and ReLU function over that. So here I am going to take from keras.layer import convolution 2D. And I am applying the convolution 2D filters of 32. 32 filters I am going to select. Each filter should be of 3 by 3 size. Filter size should be 3 by 3. The size of the filter is 3 by 3. And activation function is ReLU. Now for that, what I am going to give is input. Input shape is equal to 64, 64, 3. This is important. Here, why 64, 64 I have given? Because I have taken the data where the image size is 64 by 64. So the same 64 by 64 I am going to give here, comma 3. What is meant by comma 3 means it is a 3-dimensional array. If it is a 2-dimensional array, just 64 by 64. No need to give comma 3. Comma 3 is for 3-dimensional array. How many we are having 2-dimensional arrays? How many 2-dimensional arrays are there? 3 are there. R, G, B. 3 are there. So that is the reason 64 by 64 comma 3. Is that clear? 64 by 64 comma 3. So 64 by 64 comma 3 means it is going to select with respect to 64 by 64 pixels like that 3. In each image it is going to collect the 3. That is RGB. 64 is fixed. Yes. Here, whatever the 64 I have selected, the target size I have taken with the 64 by 64. The same thing I am going to give here. For example, here you have taken with 100 by 100 pixels. The same thing you give it 100 by 100. Right? Now, this is the first convolution. Okay, first layer. This is the first layer which I am going to apply. Convolution. Convolution means total 32 filters I am going to apply. Each filter of 3 by 3. So 3 by 3 filter means what happens? It is going to apply the 3 by 3 dot product and we are going to get a future map in this way. And for that future map, post ReLU, I am going to get a future map in this way. That is the step. For up to here, I have given the code. So 32 filters with 3 by 3 filters and I have to get the future maps. Now I am having the future maps. For that future maps, I am going to apply the max pooling. Now, what is meant by max pooling means it is going to select the maximum value within the given area. In the given area, whatever the size. Pool size is equal to 2, strides is equal to 2. What is meant by pool size means you are going to take 2 by 2. This is called as pool size. So in the last class, so here it is going to take this one pool size of 2 by 2. This is called as pool size of 2 by 2. This is pool size of 2 by 2. Pool size of 2. Now what is meant by stride? This is important. So here, first it is going to select this one. Okay, first pool size of 2 by 2. After that, it is whether it is going to select this one or it is going to start from here. Where it is going to start. Second pool, where it is going to start. This is the first pool. Okay, second pool. Second pool, whether it is going to take this one or this one. Which one? So it is going to select the blue one. So first this is the pool. After this it has to take here. So it has to consider here means I have to give the stride is equal to 2. What is meant by stride means this is called as first one. First stride, increment of 2 means after that you have to leave the next one and you have to select the next one. That is the meaning of stride. Otherwise, if you don't give the stride is equal to 2, what happens means first it is going to select this one, followed by immediately next one, followed by immediately this one. It is going to select. And output I am going to get output instead of like this. How I am going to get miss? So let us take like this 0 0 0 1 0 0 1 0 0 1 0 0 1 0 0 0. Okay. Okay. Now I am having this one. This is the okay. For this, if I apply the stride is equal to 1, pool is equal to 2, and pool is equal to 2 with the stride is equal to 2. What is the difference between these two miss? First pool is equal to 2 which stride is equal to 1 miss. First it is going to take this value. Out of this, which is the highest value? 0. Next it will come to here. Within this 1. Now again it will come to here. Within this 1. Next it will come down to here. What is this? 1. Within this it will take again. Again from this to this. Next again from this to this. So you are going to get a like the output will be like this. If you are taking a pool size of 2 and stride is equal to 1 miss, it is going to consider in this way. Stride miss, immediately next. Now stride is equal to 2. When I have written the stride is equal to 2, what happens? 0 0 0 1 0 0 1 0 0 1 0 0 1 0 0 0. Now if I apply a stride of 2, if I apply a stride of 2, first pool size of 2 by 2. So first it is going to select 0. Immediately stride of 2, not stride of 1. Stride of 1 miss, next one. Stride of 2 miss, after this one. From here it has to start. Here it has to start and it has to select the value. So it is going to take the value like this and it is going to take the 1. So that is the difference between stride is equal to 1 and stride is equal to 2. If you have written the stride is equal to 3 miss, from here it is going to start. Stride is equal to 4 miss, from here. Stride miss with respect to how much extent from where it has to start. That is the stride. Right? So here I am going to take the pool size of 2 and the strides is equal to 2. Strides is equal to miss. Immediately the next one you have to not consider. Is that clear? So here I have applied the first convolution layer followed by the max pooling. After applying the max pooling, what is the next step? Flattening. So what I am going to do? I am going to do the flattening. So I'm not going to consider this one. This particular one I'm going to ignore. Okay, directly I'm moving to the flattening. So first what I have done? Convolution. After applying convolution, pooling. After applying pooling, directly I have done the flattening. After flattening, I have taken the input hidden layer neurons is equal to 128 and output hidden layer, one layer with respect to 1 neuron by considering the sigmoid as the activation function. Right? Now, what I'm going to do, classifier.compile optimizer is equal to Adam, loss is equal to binary cross entropy, and metrics is equal to accuracy. Whatever we have considered during the artificial neural network, same to same. And you are going to fit on the train data and validation. You are going to take the test data and epochs is equal to just 25. I'm going to take only 25. For 25 only, it is going to take so much of time. Now, sir, after taking this, once 25 is completed, epochs of 25 is completed. Now the question is, sir, here you have considered 128 neurons, question number 1. And you have taken only one hidden layer with 128 neurons. Why? Question is why? Why you have considered only one hidden layer, and that too why you have considered only 128? Question number why. Second one, here you have taken a second hidden layer, second convolution layer. One more convolution layer is there. Now the thing is, first time when I am applying, just I have taken the target of 64 by 64, and I have applied the convolution operation, followed by max pooling, followed by flattening, followed by neural network. Now, after seeing the accuracy, now I am going to get some accuracy, right? Once the 25 epochs is completed, I will get some accuracy. Assume the accuracy I have got is 65%. Now, 65% accuracy is not sufficient for me. I want to increase the accuracy. What are the options to increase the accuracy? Miss, option number 1, increase the number of hidden layers. So what I'm going to do, I'm going to add one more hidden layer. This is my first hidden layer. After this, immediately, okay, after this, I'm going to add one more hidden layer. I will add one more hidden layer, copy, and I will add one more hidden layer. Automatically in the order, once you are adding first hidden layer, second hidden layer, followed by output layer. Whatever the order you are adding, it is the order, right? Till this input layer, this is the first hidden layer, this is the second hidden layer, this is the output layer. I will add one more hidden layer. After adding one more hidden layer, I have got with the accuracy of 68%. Okay. So if I add hidden layer, means only 3% is increasing. So hidden layer is not having that much impact. Let us try with convolution layer. I am going to add the second convolution layer, means one more 32 filters. One more time, I am going to add the convolution layer with max pooling. So if I add this one, again, I will observe what is the accuracy. I will get this time the accuracy as 84% or something like this. Oh, if I am adding this convolution layer, it is going to increase the accuracy. So what, from this, what we'll understand? Okay, we'll add one more. Like this, we are going to add like that, in that way. First time itself, no one knows the exact values. How many convolution layers we have to select, how many number of input neurons we have to, hidden layer neurons we have to select, and how many number of hidden layers we have to select. No one knows. First time we are going to give some value, and second time we are going to change the value, and we are going to see the improvement or deprovement. Same to same how the artificial neural networks works on the trial and error. Initially, it is going to initialize some weights. How it is going to initialize the weights, and later it is going to adjust the weights. In the similar manner, first we are going to give some input neurons. Hidden layer neurons. Okay. Here the number of filters is equal to 32, is not fixed. Okay. Kernel size of 3, that is fixed. Any filter will be kernel size of 3. And max pooling, pool size of 2 and strides of 2. This is fixed. This part is fixed. Number of filters, why you have considered only 32, sir? Instead of 32, why you can't consider 100 or 200 filters? So what I'm going to do is, first, I don't know anything. I don't know number of filters. Number of filters is unknown. I don't know. Next, what is unknown? Number of hidden layers. Number of hidden layers is also unknown. In that hidden layers, what is the number of neurons I have to select? This is also unknown. 3 of them are unknown. I don't know anything. Right? So, based on the output only, we are going to assign the values. Is that clear? So, tomorrow, if you want to do some kind of image classification, assume that you are sitting in a project. Okay? You are sitting in a company and you are sitting for a project where that project is image classification. For image classification, you have to divide the given data into these classes. Whether you have to predict whether this belongs to either this class or this class. Okay. Now they have given the data set like this. Business problem is completed. What is the data understanding? For image classification, what is the data understanding? What is the EDA? No EDA, no data understanding. Is there any data cleaning? No data cleaning. Is there any data wrangling? No data wrangling. Then what is there? Train test split. You are going to divide some images for training purpose, some images for testing purpose. For example, they have given you total 1 lakh images they have given. Assume in your hard disk or in the database, 1 lakh images are there. What you are going to do? you are going to create one separate folder for training. You are going to keep that folder name called as train. In that, you are going to copy some 70,000 images. You are going to copy into that. 30,000 images you are going to copy into the test. Randomly you are going to choose. Okay. Now, train test PT is also completed. Now, what is the modeling? Modeling means just you have to apply only CNN. Only option we are having is CNN. So we are going to apply the CNN. Now, CNN, if everything is fixed, 64 by 64 is fixed, number of filters is fixed, number of layers is fixed, everything is fixed means generally that image classification project, how much time it will take in the company? Maximum 1 day, right? If everything is fixed means 1 day. Means 1 day project also will be completed. Huh? If they give morning data set means evening itself, you will give the submit the answers. Huh? If everything is fixed means by how much time it will take for completing the 25 epochs. So already 4 epochs are completed. Means 5 minutes, 5 epochs are completed. 25 minutes, 25 epochs means 25 minutes. In 25 minutes, you are going to complete the 25 epochs means you have to get immediately correct answer. Within 25 minutes, you have to complete the project and you have to submit to your project manager. Right? So think practically. So in the companies, once they have given to us the image classification data set means we don't know the number of filters, how many to apply. So first we are going to apply with by considering the 32 filters. Randomly I have chosen 32 filters. And after that, I'm going to adjust myself. After seeing the accuracy, after that, one more time, I'm going to adjust. First time itself, I don't know that I have to add this second convolution layer. First time, I don't know this one to add. I don't know this one. Directly, I'm having only the convolution, pooling, flattening, and hidden layer. One hidden layer. Okay. That too, my trainer has explained me the hidden layer in the artificial neural networks. He has taken the hidden layer only 8 neurons. So I'll start with only 8 neurons, even not with 128 also. 8 neurons only I will consider. First, I will start like this. I will get with very low accuracy. Now I want to improve the accuracy. Now I will start with respect to increasing the number of hidden layer neurons or hidden layers, number of hidden layers. Either hidden layers I will increase or within the one hidden layer only I will increase the number of neurons and I will check. After half an hour, again I will get the result out. For each time, it will take half an hour time. For after half an hour, again it is going to give me the result. And I will see the again accuracy. Now I will change. Again, I will wait for half an hour. Again, it will give some answer. Again, I will wait for half an hour. Like this, I am going to change so that I will get still the better accuracy. Wherever I get the better accuracy, that particular neural network, I am going to fix and I am going to test on the test data. In the future data, I will try myself. Some images I will extract from the website and I will check myself whether it is working properly or not. Is that clear? Nothing is fixed. So, sir, you are asking the question, sir, 64 by 64 is fixed. Filters 32 is fixed. Pool size of, number of hidden layer neurons 128 is fixed. And with respect to number of hidden layers, one hidden layer only fixed. All these questions, answer is nothing is fixed. If everything is fixed means image classification project will be completed in 1 day in the company. For example, in the company, we are doing assume that we are working on the regression. If you are working on the regression, do you require the classification algorithms? Just we are going to apply only regression algorithms. Business problem understanding, EDA, and whatever the data pre-processing or anything. And we are going to apply only regression algorithms. If you are working on the classification, do we require regression algorithms? No. If you are working on with respect to clustering, do we require these two? Again, no. If you are working only on one thing, for that one thing only, they are going to give you 3 months to 4 months of time. Image classification also will not complete in 1 day. Here I have considered only a small size of data set where with 10,000 images I have selected. Out of 10,000 images, 8,000 images I am using for training purpose and 2,000 images I am using for testing purpose. In real life, you may get with 1 lakh or 10 lakh records. At the time, you are going to work with respect to 1 by 1. Okay, everything is fixed means, remember, if everything is fixed, code is fixed means, then what you are going to change? Assume in your company, they have given you one different data set. If entire code is fixed, then what you are going to do? Just you are going to change the directory. Just you will come to first line and you will change only the this first line. Just you will come and change the first line that here whatever the directory is there, that directory you are going to change. Wherever your images are there, you are going to keep the directory. Only one line you will change and you will get the salary. For changing one line, they will pay for your salary. No, right? So you have to work. So these things, first what we are going to do is, first we are going to apply the model, convolution, pooling, flattening, and after that full layer. And after that, we are going to see the accuracy. So here, if you observe this accuracy, as of now, accuracy is 78%. If your 78% is satisfied for you, means you can stop even for the 8 epochs only. Even 25 epochs also not required for you. The more the accuracy you want, means we have to change the different values. See here, assume that I have given initially 64 by 64. Okay. And filters, 32 filters I have given. Okay, 32 filters. This is initial. Initially the size. Initial size. Number of filters is equal to 32 by 32. Number of hidden layers. Number of hidden layers is equal to 1. Number of neurons in that hidden layers is equal to 128 I have given. And I have got, assume that 72% I have got. Okay, first initial answer, this I have got. Now, I got an idea. Now, to increase the accuracy, what I am going to do? I am going to increase the number of hidden layers to 2. Okay. In each hidden layer, same 128. One more hidden layer I am going to add. I am going to, remaining everything is constant. This is constant, this is constant, this is constant. Only changes in here. Now I have got 74%. Now from this, what you are understanding? If you add one more hidden layer, what happens? It increases the accuracy of 2%. Now what you are going to do? You are going to increase one more hidden layer. 3 hidden layers. Neurons, we are going to keep the same. Now you have got 75% only. Now what you will understand? Okay, number of hidden layers increases also. It increases just of 1% or 2%. Okay, now you will stop here. Now, this is option number 1. You tried. You tried with this option and you have checked if you increase the number of hidden layers, what happens. Now what you are going to do? Instead of one hidden layer of 128 neurons, I will take 500 neurons here. And I will observe. Now again, you will see some accuracy, some value. And by seeing this one, for example, you have got with respect to 73% of 73.2 only. Okay, number of neurons from 128 to 500 increase also. The increase in the accuracy is just 1%. If I want 28% neurons, I want 28% of the things I want to increase, means how many neurons I have to add? So much of neurons I have to add. That too, it is going to take so much of time. Then what is the other option? So this one also I will keep as it is. What is the other option? I will try. Now filters. I will come to the filters. Instead of filters of 32, I will take 100 filters. I will try with 100 filters. Now again, I will observe. I will get some kind of accuracy. How much time it is taking for this one? And based on that, I'm going to adjust myself. How in the gradient descent algorithm is going to adjust the weights and it is going to minimize the error. In the similar way, you are going to change this one. These values are not fixed. Everything you are going to change. Is that clear? Right? Now, so once the 25 epochs is completed, one student is saying that Alok, it is not audible. Others, can you please confirm it is audible or not? Yes. Done. So here, once the 25 epochs are completed, now what I am going to do? I am going to evaluate. How I am going to evaluate means from a NumPy, import NumPy as NP. From PIL, there is a library called as PIL. Inside that, there is an option called as image. Image.open. I am going to open the image within the data set. So it is going to open in my working directory. In my working directory, this is my working directory. In my working directory, data set. Inside the data set, single prediction. Single prediction means this one. Inside the single prediction, it is going to take cat or dog underscore 2.jpg. So cat or dog underscore 2, this one. This image it is going to select. Only one image. Only one image, not from the flow. Only one image it is going to select. This one image, whatever the image is there, this image I'm going to resize to 64 by 64 because my model was designed for 64 by 64. So I have to transform the data to 64 by 64. Once I have converted this one to 64 by 64, now I'm going to convert this one to an array. Array means one-dimensional array. Means after flattening, once you have done the flattening, you are going to get. Now this image, you are going to send into the classifier and you are going to predict. Classifier dot predict. Classifier means what is classifier? Whatever your model is there, your model name is called as classifier. Classifier dot predict. Your model dot predict on the test data. Test data means whatever you have given this image, and if the result is equal to 1, in the index of 1, what is there? Dogs or cat? Dog. Index of 0, cat. So result index number is equal to 0 means cat. Index number is equal to 1 means it is called as dog. You are going to check in this way. Is that clear? So once the modeling is completed, so 25 epochs means it is going to take at least half an hour to 45 minutes of time. Okay. So if let us assume there is a value like this. Three, 7. Okay, here it is pure black color. Okay, this is also pure black color, and this is pure black color, and this is pure black color. Now, basically, when you read the image, when you read this image without doing the rescale of 1 by 255, when you have read this image, what happens is, in this case, it is going to take 255, 255, 255, 255, 255, 255, and 255. So it is going to have in this way. The values will be with 255 because that is pure black color, right? Whatever the black color is there, that 255 it is going to select. It is going to take with respect to the value of 255. Now what you are going to do, this 255 you are going to divide. Now what happens? You are going to get an image finally. Wherever the 255 is there, that is it is considered as 1 divided by 255. Now you are going to get only zeros or ones in the image. By default, it is 255 right here. Once you divide that data by 255, you are going to get either zeros or ones. Wherever the pure black color is there, that is 1. For example, light black color is there. Okay, let us take in this particular location, light color black is there, light black. Okay. So where this around 120 is the pixel intensity. Now 120 divided by 255, some percentage will be there, some value, right? That is 1 by 255. 255 means it is going to just divide with respect to that. Is that clear, guys? Any questions? So convolution neural networks means just it is going to classify the images. So you are going to train the both classes, whatever the classes you are having, you are going to train the both the classes of images and you are going to classify them. It is going to do the just classification, right? Next, called as computer vision. Now what is computer vision? And how a computer reads an image. Same to same. Earlier, whatever the computer has read the image in the same way. Black and white image means it is a 2-dimensional array. If it is a color image means 3-dimensional array. Where for the color image, RGB will be there. Red, green, blue. If it is a black and white image means only black and white. 2 only will be there. It is a 2-dimensional. And now what is OpenCV? OpenCV is a library name. Okay, it is OpenCV is called as library name. Concept name is called as CV. Computer vision is called as concept name. OpenCV is called as library name. Okay, so what is OpenCV? And inside this OpenCV, what we are going to do? See here, this only one image is there. Image is only one, but inside the image, it is identifying the various objects. In the Facebook, if you give one photo miss, it is identifying with respect to face. Multiple faces and it is going to show the name, right? It is identifying the names of the persons. various persons which are available in the database. For example, if you have taken my photo and you have kept in the Facebook, it will not show the SRK because my photo is not there in the Facebook. I'm not having the Facebook account. Okay, none of my photo is there in the Facebook. So it is not going to capture in the face will not be captured mine. But if you have taken with respect to your friends, some of your friends you have kept inside that, automatically it is going to show you the tag. It is going to show with respect to face tag. If whatever the name you want, you can write that name, right? So here, computer vision is going to identify the multiple objects within the image. It is not going to do the image classification. Within one image only, it is going to identify the various objects. That is the difference. Is that clear? So for example, you are having here in the convolution neural networks. Let us take like this. For example, I have given this image. This image is whether it is a cat or a dog. Whether it is a cat or a dog means image classification. I'm not asking image classification. Inside this, what are the different objects are available? One is cat object is available. One is some kind of wall is there. Right? And some kind of carpet is there. Below there is a carpet, some kind of. So here, what are the different objects are there? In this image, what are the different objects are there? Whether it is a cat or dog, that is secondary. What are the various objects here? I'm having one kind of plastic bin is there. Plastic cover is there. And with respect to cat is there. And we are having some kind of wooden is there. Like this, we are having multiple things are there. Right? Whatever we are having. So there is a person. There is a case. There is with respect to a cat. So what are the different objects are available within the given image? Identifying the various objects in a single image is called as object detection. Object detection will be done by using the CV. Object detection cannot be done by using the CNN. CNN is classifying. It will classify either this class or this class. But within the one image only, if you want to identify various persons or various objects, if you want to identify, then we have to use the CV, computer vision, right? Now, computer vision, where we are able to identify the multiple objects in a single image, right? Now, how a computer reads an image means it is going to read as a RGB. A color image will be taken as RGB sensor, where it is going to have total 3. One is R, one is G, and one is B. So, any color image is a combination of how much percentage of redness, how much percentage of greenness, and how much percentage of blueness, right? RGB sensor. Right? Now, what is OpenCV? OpenCV is a library which was integrated along with the NumPy. Okay, automatically it has converted to an array. Once you give an image, every image will be converted to an array. Right? Now, what are the basic operations we are able to do with the OpenCV? Convolution neural networks and OpenCV, both of them, what is the common thing means both of them are going to work on the images. That is the only common thing. CNN is purely image classification. CV is object detection. Both are independent to each other. There is no common point. In working, there is no common point. Just both of them are working on the images. For example, you have taken in this class, students are sitting. Multiple students are there. You have taken a group photo. Okay, you have taken a group photo. In this group photo, multiple students are there. Which identifying the each student is the CV. Whether they are students or whether they are animals, that is image classification. Right? So image classification means completely with respect to a group of, for example, a group of animals are there. A group of animals are there. A group of people are there. Okay, this one is the group. This one also a separate group. Within this group, identifying the tiger, lion separately is with respect to CV. By giving one of the example, like Modi example we have given. Modi belongs to animal group or Modi belongs to person, a human being. That is called as image classification. That comes under image classification. Is that clear? Now, what are the basic operations we have? So when compared to CNN, CV is easy. Compared to CNN, CV is dead easy. Right? Now, so first what we are going to do is, first we are going to import the CV2. Okay? Import CV2. CV2 means computer vision. Latest version is 2. So CV2. And import the NumPy as NP. You are going to import the NumPy as NP. Okay. And if you want to see the version, whatever the library, if you want to see any version, miss the library name dot underscore underscore version underscore underscore, right? For anything, this is the common one. Yeah. So import CV2, import NumPy as NP, and CV2, if you see the version, I'm working on the version is called as 4.6. Now, what I'm going to do is CV first one in the CV2 library, first function is called as imRead. imRead means image read. It is going to read the image. Im stands for image. Read means it is going to read the image. So it is going to read the image. In my working directory, there is a folder called as image underscore examples. So it is going to open your working directory. Modi.jpg means it is going to select this one. Okay, this file. Comma 1. What is meant by comma 1 means it is going to read as the color image. The image will be set as a color image. It is going to read as color image. 1 means color. If you give instead of 1 0 means it is going to read as a black and white image. Okay. Now if you print the CV2.imRead. imRead means it is going to read the whatever the image underscore examples folder is there. Inside that modi.jpg, that particular file it is going to read as color image. It is going to read. Now if you print img, so it is going to print the three-dimensional array. It is going to print as a three-dimensional array. Can you see total 3 dimensions? So where we are having with the 255 means the color, RGB color, whatever the color we are having, the colors, it is going to show the colors, right? Now, if you see the shape, just right click and click on the properties. And if you see the details here, what is the shape? 1358 is the height and 1500 is the pixels. So 1500 comma 1358 we are having the same thing. Just if you call image 1358 comma 1500 comma 3. What is meant by 3? 3-dimensional array. So total 3 are there. 3 2-dimensional arrays are there. Okay. For example, if you take a cube, your Rubik's cube, everyone knows Rubik's cube. So now what is the Rubik's cube shape? In front, what is the front? In the front, what you are going to see? 3 by 3. Like this 3 by 3 total, how many are there? 6 are there. 6 faces are there. So the Rubik's cube shape is 3 comma 3 comma 6. 3 by 3, like that 6 faces are there. This last number indicates how many 2-dimensional arrays are there. Okay. Since here RGB sensor 3 are there, RGB 3 are there. So it is going to show the number 3. For example, one more color is there, like orange also is there. Assume RGBO, something I am having like this. Then it is going to show 4. Right? Now here, if you observe this one, the shape is 1358 into 1500 comma 3. Now, sir, here you have considered this is as a Modi image, as a color image, it is showing like this. Let us keep the comma 0. Now you can identify easily. What I have told, comma 0 means what is the meaning of comma 0? Black and white. Now it is going to take it as black and white. Now if you see here, it is a 2-dimensional array or 3-dimensional array? 2-dimensional array. Just 2 brackets are there. In the earlier example, have you observed that opening brackets, 3 brackets are there? If you want, you can see once again. I'm keeping 1. And now you can see here, how many open brackets? So this is first 2-dimensional array. This is first 2-dimensional array. This is one 2-dimensional array and one more 2-dimensional array. Multiple 2-dimensional arrays are there. Multiple 2-dimensional arrays is called as a 3-dimensional, right? Now, if I keep the 0, comma 0. Now, what is comma 0 means black and white, where black and white is a 2-dimensional. Now, if you see here, 1358 comma 1500. NumPy dot shape For one dimensional, how it is going to represent? Just whatever the number of elements are there. For example, 40 elements are there, 40 comma like this. The second value will not be displayed. For two-dimensional array, 40 comma 40. For three-dimensional array, 40 comma 40 comma. Like this, how many are there? How many multiple two-dimensional arrays are there? 3 or 2 or 4 or 5 or whatever it is. Here, total number of things indicates what is the number of dimensions it is having. Right? So here it is a two-dimensional array. So black and if I keep the 0, it is considered as a black and white image. Now I'm keeping as 1. Again, coming back, I'm keeping as 1. It is a three-dimensional array. Now, this I don't want as a numbers. I want to display as the photo. Whatever the photo it has read, that photo it has to display. So the image, it has to show me the image. So for that, what we are having means IM show. In the CV2, we are having an option called as IM show. IM show means image show the image. And how it is going to show the image, namo, comma, img. Namo means in terms of, it is going to create a separate tab. So it is going to take a separate tab. See, it is going to create a separate tab. In that separate tab, it is going to show. Okay. So where it is going to show me the image, whatever the image I have taken, that image it is showing. Sir, okay, sir, image it is showing. Now what is this namo? Namo means nothing but for this tab, whatever the tab it is showing, for this tab I have kept the name. Multiple images if I am seeing the multiple images, each image will have some names, right? For this tab, the name I have kept as Namo, something. And NA stands for Narendra and MO stands for Modi, right? Shortcut I have created like that, right? Now here, Narendra Modi, just I have kept the name. Whatever the name you are interested. If you are interested like PM, keep it as PM. So tab name is PM. Whatever the name you have kept, it is going to show, right? So it is just showing the image. What image it is showing? IMG. What is IMG? IMG is nothing but whatever you have saved. What you have saved? Modi.jpg. You have saved like this. Sir, now I am keeping as 0, comma 0. Comma 0 means black and white. Now, image is like this. I don't want like this. I want to see the photo. Just in one shot. Comma 0 means black and white image you can get. Any color image you can convert to black and white image just by keeping comma 0. Even your photo also you can convert to black and white. Converting a color image to black and white is easy, but black and white to color is difficult. Black and white images to convert to color means that is difficult because, for example, Modi shirt is there. Modi shirt he has wear with orange shirt also, we can convert to black color. Pink color shirt he wear also, I can convert to black color. Blue color shirt also I can convert to black color. From black to which color I have to convert? Which color, exact color shirt he has wear, I don't know, right? Any color shirt I can convert to black, but normal black to again to that color means I have to know exactly what is that color. Then only I can convert. Otherwise I can't get that one. Right? So converting a color image to black and white is easy. Right? Now here if you see, sir, this is the Modi image which you are collecting. So here the entire photo is there, where the face is there, down there is a coat and along with the shirt, everything is there. But when you are showing in the tab, once you are clicking on this, it is not showing the complete image, sir. Why? Down part is not displaying, right? Only upper part it is displaying. 1500 into 1358 pixels. 1500 into 1358 pixels. But my monitor, whatever the laptop monitor is, it is the maximum. This is my monitor, maximum capacity is 1368 into 768 only. So out of 1358 pixels, only 768 pixels are displaying. Down part it is not displaying. That is my maximum capacity. If my system is 4K resolution, 4K resolution means up to 4000 pixels it will display. The entire image will be displayed. But my system is of only 768 pixels maximum. So that is the reason it is not displaying the down part. Sir, it is not displaying the down part, but we have to see the entire part means then what we have to do? We have to resize. We have to resize. Right? So here cv2.im show. What is meant by im show? Image show. It is going to show the image. And what is the name you have kept? This is the tab name. and this is the variable. Which variable you want to show? That variable. CV2 dot wait key. Okay, there is an option called as CV2 dot wait key. What is this CV2 dot wait key means? It will wait until you close. It will wait like this. It will wait until you close. For example, here inside this you have given 10,000. Something you have given. It will automatically close after 10,000 milliseconds. See, once this is open, I'm not doing anything. After 10,000 milliseconds, it will close automatically. Okay. So, for example, you have given with 20. After 20 milliseconds, it will close. I have not closed. Automatically, it has closed. Right? That is meant by wait key. For example, I have given with 10 milliseconds. Okay. And I am executing. The cell number is 25 and I am executing. 10 milliseconds, how much time it will take? Closed. Open and closed. And 100 milliseconds. If you give 100 milliseconds, right? So this is nothing but number of milliseconds it is going to wait. If you don't give any value, it will wait until you close. Wait key means wait till the person is going to enter the key. Wait till the person enters the key. That is the meaning of wait key. Right? Next, CV2 dot destroy all windows means when I'm executing this particular cell, before to this, whatever the tabs, remaining tabs are open, right? All the images, please close that one. Close all the remaining windows. It is going to close all the remaining windows before to this. So here I have written you first. I have read the image. After that, I have IM show, wait key, destroy. So here I'm writing everything in a single cell only. IM read, image underscore examples is the folder. Inside that modi.jpg, comma 0. Comma 0 means black and white. It is showing me the black and white image. Everything I'm writing in a single cell. Why I have to write in the multiple cells? If I write one, color image. Right? Now, if you want to save the image, any image if you want to save, for example, Modi image is there, black and white. Okay, this black and white image I want to save. Okay, after converting to black and white, now I want to save this one. How to save means IM write. IM write means image write. IM means image. Write means save. So you are going to save as a PM underscore B underscore W dot JPJ. You are going to save this one as a file name. Okay, where this IMG means whatever you have stored, this is 0, right? This part, that is Modi image in black and white. Modi image black and white, you are storing in the variable called as IMG. This IMG, you are going to save. You are going to click on the save. And once you have clicked on the save, it is going to store in your working directory. Just open your working directory. In the working directory, it is going to create that one, black and white image. Right? So here, just once you executed, it is going to save. Now, if you observe this one, just now it has been created. If you want to resize, I'm going to resize. So I'm going to read the image. Image is equal to image underscore examples modi.jpg. Now, image, whatever the image is there, that I'm going to resize. Resize to 679, 750. Sir, why you have selected 679, 750 only? 1358 and 1500, whatever the pixels are there, into 50% I am considering. I am reducing the size to 50%. 50% means 1358 into 0.5, 1500 into 0.5. This is 679. This is 750. Means I am reducing the picture size to 50%. Okay. So now I am going to select this one. Now if you see here, first, IMG is equal to CV2.IMRead. So you are going to read the image. I'm going to keep comma 1, comma 1. Comma 1 means color image. It is going to read as a color image and I'm going to save in the IMG. I'm going to save in a variable called as IMG. Now this IMG, whatever is there, I'm going to resize it to 679, 750. Now whatever the resize image is there, that I'm going to store in the resize underscore image. This is a new variable. This is the original one. This is the resized one. Now I'm going to write CV2.IMShow. Resized image. Resized image means it is going to show this image, not this image. If you write here IMG. Now, if I am writing IMG, it is going to show the original image. This is the original image. Now I am going to write the resized image. Resized underscore image. Whatever the resized image is there, now you can see the resized image. Size was reduced. Instead of 1358 into 1500, the pixel size was reduced. Is that clear? Now, for example, instead of 679 into 750, instead of that, 64 by 64. The pixel size of 64 by 64. This is the pixel size. That is a pixel size of 64 by 64. For example, you want to give with a 640 by 64. It is going to have 640 width, 64 height. This is the width and this is the height. 640 by 640 according to that. So once you close 640 by 640, this is 640 by 640.